But having less fuel in the center tank can create a potential hazardous condition that came to light after the TWA Flight 800 mid-air fuel tank explosion. Let's understand what caused the center tank of the jumbo jet to explode. 3 conditions were necessary for the explosion to take place. First, oxygen in the tank to support combustion. Second, fuel vaporization. Fuel in its liquid form is not flammable, it needs to vaporize before it could ignite. And for the fuel to vaporize, it needs to reach its flash point of 38 degrees Celsius. Temperature in the fuel tank can never reach that level, due to ambient temperature conditions. But the heat generated by the air conditioning packs of the aircraft, located just below the fuel tank, caused the temperature to rise well beyond the flash point. Finally, the spark to ignite the fuel-air mixture. The electrical components in the tank, such as the fuel quantity probes, are designed to work on a very low voltage. This ensures any malfunction of the system does not create a spark inside the tank. But the wiring of the system outside the tank ran alongside other high-voltage system wires. An electrical short between the wires caused a spark that led to the fuel tank explosion. The investigation revealed all commercial aircraft, with a similar design configuration as the 747, are vulnerable to center tank explosion. This led to improvement in wire separation and maintenance standards. Better insulation between the fuel tank and other heat-generating equipments. But most importantly, a new system to be installed on the aircraft. The nitrogen generation system. Any given volume of air is approximately 78% nitrogen, 21% oxygen, and 1% other gases. The NGS uses the left bleed supply to generate nitrogen. The bleed air temperature is significantly high for the system to work. Therefore, the air first enters a heat exchanger, and the aircraft ram air door opens to cool the flow. From the heat exchanger, the flow gets transferred to the air separation unit. The unit separates the flow into 2 parts. Oxygen-enriched air is discharged overboard, and nitrogen-enriched air is transferred to the center tank of the aircraft. The NEA replaces the air within the tank, which vacates through the vent. As more and more nitrogen is pumped into the center tank, the oxygen level inside the tank depletes. The system ensures the level of oxygen in the tank is below 12%. At such low level, the oxygen will not be able to support combustion.